How can blockchain transform government? The blockchain is one of the most significant fundamental advances in digital platforms since the internet, and also probably the most overhyped technology in current times. In many ways, blockchain could be compared to the growth of internet back in the 1990s. With that being said, there's obviously a lot of infrastructural problems and trouble points that still have to be figured out. Blockchain also has a great deal of fraud, illegal activity, and regulatory arbitrage, but it's also one of the most innovative creations of recent times. While most people use the term Bitcoin and blockchain interchangeably, they are very different things. At bottom, blockchain is not about money, even though this is the technology underlying Bitcoin and other cryptocurrencies. And it's not fundamentally about destroying government and replacing them with purely private, decentralized systems, even though it is a system that creates a new kind of decentralized infrastructure. Fundamentally, blockchain is about something deeper than all that. It's about trust. Moving on to Equifax and the role of intermediaries. Recently, a company most Americans don't know much about was hacked, and the private data of 146 million people, including their social security numbers, was exposed. With its rich repository of private data, credit bureau Equifax became a target of hackers, and the reason why the company and other credit bureaus exist in the first place is due to a lack of trust. Equifax provides credit scores so a bank, car dealer, or other lender will have a sense of whether a borrower will pay back a loan. The point of Equifax and credit bureaus is not to have credit bureaus. It's to have a mechanism so that a distributed world of actors, companies, and individuals can engage in loan transactions with some sense of what people's credit worthiness is. But imagine if those same transactions could be done without central trusted intermediaries. It would be much more secure and also much more efficient. Firms like Equifax charge fees for being an intermediary, and going through them also adds delay to a transaction. The basic idea behind blockchain is that one can trust the system as a whole without necessarily trusting any of the participants. The blockchain is a ledger, which is a record of transactions in a database, distributed to people in a network. Everyone on that network has their own copy of the ledger, and it's actually very confident based on mathematical structure of cryptography that every copy is the same. So even though there's no central intermediary like Equifax, a bank, or the Federal Reserve, all the players in the blockchain network can trust the information. And there's only one ledger in any given blockchain network, and everyone works off that record. Each participant gets a copy of the ledger, and additions to the record cannot be changed. With all eyes on it, there's no need for a trusted institution to be in the middle to charge fees or delay transactions. Everyone can maintain their own copy, even across different organizations and across different countries. And this seemingly basic abstract ideal is what has led to all the excitement and adoption across blockchain and cryptocurrencies. The excitement around this innovation has pushed the value of Bitcoin to over $1 trillion worldwide, while cryptocurrencies in circulation are worth around $900 billion. This number just continues to rise with each passing year. But there are still many issues to overcome. It's incredibly early, and this is not a mature technology. There's great uncertainty, and there's all sorts of problems, even basic technical problems that need to be worked out, and there are all sorts of non-valuable applications. There are people using this, for example, to commit fraud, or using this capability to engage in money laundering and illegal transactions, and all sorts of regulatory uncertainties. However, these challenges are not indications that this technology is fundamentally flawed or is fundamentally fraudulent or a Ponzi scheme at heart. Now, why blockchain shows promise? To be sure, one doesn't need the blockchain to keep a record of transactions. Any centralized database can do the job. However, there are large swaths of activity where no database will actually get deployed or actually be successful because of basic trust problems. Sometimes the level of trust is too limited. For example, two companies that enter into a transaction will typically not trust each other. So they each maintain a record of their transaction. If it's a more complex deal, they have more copies and have to reconcile them back and forth, he said. That leads to delays, duplication, additional cost, and errors. One example of how the blockchain can improve operation is in supply chains, where goods and services flow among many different organizations around the world. Delays come when the companies in the supply chain are not willing to share their data with each other, so there's a lot of back and forth involved. But the blockchain can solve this problem. We can look at Walmart and their use of blockchain to track its produce. Before, if someone got sick from the produce, it would take the retailer 6.5 days to find out which farm it came from. After using the blockchain, Walmart got it down to 2 seconds. The other potential value of the blockchain is that once a network is set up, it can be a platform for smart contracts to run on top of it. These are software applications that automatically execute the rules programmed into it. For example, a smart contract on a car loan gives the driver ownership rights while he continues to make payments. If he misses payments, the contract would trigger a process to repossess the car, and ownership would revert to the lender, all done without an intermediary such as a repo agent or a collecting agency. For the government, smart contracts can have implications on how it can regulate more efficiently. For example, auditing functions can be embedded in the smart contract itself, so audit doesn't have to come in by third party forensically. The transactional data can be readily available on the blockchain itself, including to regulators. The government does not have to rely on records a company provides to audit transactions because it can see the record on the blockchain. There's 2 broad approaches comprising the blockchain innovation. One is the crypto economic system such as Bitcoin and other cryptocurrency tokens. In this system, the goals and incentives are the cryptocurrency itself. For example, Bitcoin miners expend plenty of electricity and computing power to secure and validate blocks of transactions in a blockchain network. The reward is Bitcoins, and Bitcoins depend on Bitcoin to incentivize miners who are investing their resources. Their tokens become an incentive for behavior. And the other approach is what's called permission systems. In this setup, the participants all know each other, so there's no need for the overhead of the mining and validation process. You can create a shared environment. No one's in control, and everyone has the same copy of the ledger. It's still decentralized, but participants can much more efficiently use that shared ledger. Applications for government. At a time when trust in the government is an all-time low, systems that don't rely on trust have tremendous potential. Also, government resources are constrained, and so blockchain-based solutions that wring cost out of the systems are helpful. Moreover, blockchains tend to be incredibly secure systems because they decentralize out this process of security and create an alignment of incentives to secure the network. They're designed around an information security and cryptography paradigm that puts security at its core, and they allow for this integral accountability in the system itself. Critics might question the security of Bitcoins after high-profile thefts at several cryptocurrency exchanges, but in actuality, Bitcoin is quite secure. Bitcoin is a public 100 trillion plus bank vault. It's out there. Anyone could hack the Bitcoin network. Nobody has been able to do that in 9 years of trading. Where Bitcoin has been stolen is at the edges. For example, when Bitcoin leaves the blockchain vault and goes onto an exchange and the exchange gets hacked. Using Bitcoin though makes sense for the government because much of what it does is actually record keeping. This can be put on a blockchain to make them more secure and more accessible. For example, Cook County in Illinois put its title registration on a blockchain. Once it is recorded, no one can change it. This can be the foundation for smart contracts to handle liens on properties or the need for additional information. In Delaware, the blockchain is used for corporate share issuance. When an investor buys a stock, it is technically owned by the depository, trust, and clearing company. If you own that stock, this system would grind to a halt because you'd have to trade the physical stock certificates back and forth each time. That's why Delaware used the blockchain, and the company has the added benefit of seeing all its investors in real time. West Virginia did a test pilot to use the blockchain for voting in its recent primary. The target was military service members deployed overseas. If someone's on an aircraft carrier, it's harder to get them an absentee ballot to vote in a primary. The state hired a vendor to create a system that lets overseas military securely vote using a mobile device, and all of it is recorded on a blockchain. This potentially uses the immutability of the blockchain as well as native digital accessibility. With that said, the security experts still have concerns about using it for voting. The question is, where is the real challenge? Is the problem of information security in elections the core record, or all the things around the edges? The blockchain might be secure if there's malware on a voter's mobile phone that is used to cast a ballot. Maybe it could change the vote. Blockchain at the core doesn't necessarily solve that problem. Another use of the blockchain by government is for distribution of benefits. One example is the United Nations World Food Program that provided cash transfers to Syrian refugees in Jordan. Not only did the blockchain system save money by avoiding bank fees, it enabled the refugees to buy foods from local merchants through a biometric scan of their eye. They did not need any physical cash, vouchers, or electronic cards. Compliance is another area where governments using blockchain can boost efficiency by eliminating some of the intermediaries. For example, tax collection goes through several intermediaries and steps. Putting it all on one ledger potentially eliminates those and creates this environment where regulators can direct access to the transactional data. This has great potential for a whole variety of regulatory contexts where traditionally the process of keeping track of activity was something that had to happen after the fact. Government borrowing can also be transformed by the blockchain. Example is Berkeley, California. In May of 2008, city officials voted to issue microbonds in denominations of $10 to $25 to raise money for community projects. The typical municipal bond size is $5,000 at minimum. Typically, finance fees for issuing municipal bonds is such that it would not be feasible for small amounts. But the blockchain cuts those costs because it lets the government deal directly with the buyer. This setup essentially gets around the Wall Street aspect. The Berkeley pilot does not require centralized intermediaries. The value transfer happens directly and potentially allows for much more efficient transactions and allows for much smaller value transactions with the direct maintenance and tracking of the information. Smart contracts can be used to manage, track, and implement the interest rate process, the repayment process, and the securitization process of these bonds